All right, so recording for the rest of 1.15, we're actually going to hit these 3 AP type questions. One of them, everybody ought to know how to do. The other one, very few people across the world knew how to do, and I'm going to talk about the specifics of that one. So I've got 2 what I call level 5 plus, which means if you don't understand it, probably won't affect much of anything, but I like to hit some of those higher level thinking questions for those of you going on to higher levels of math. But I don't put the 5 plusers on your test unless I say that they're bonus. Does that make sense? So just nod and smile if you don't understand this second one, but this first one we ought to know. So we're going to go right here. This was off of the 2012. It was AB number 21, and what that means is there was no calculator because the first 30 are without a calculator. So without being able to look at the graph, students needed to know the concept, the calculus concept of a horizontal asymptote. Remember that in pre-algebra, they're all polynomial over polynomial, which works for C, D, and E. But in calculus, what happens is a lot of times you need to consider horizontal asymptotes as the limits as we approach not one, but both infinities. They might be the same, they might be different, or maybe to infinity there is one, but to negative infinity we go down forever. You need to consider both. All right, so I'm going to talk about which ones don't work up here first. One of the functions is a line. And lines are unbound in both directions. So it's obviously not going to have a horizontal asymptote, right? So let's play the who it's not game first. Which one isn't it for sure? B is out. Okay? B looks like this. There's no horizontal asymptote for any kind of a line. Okay? Another one has a horizontal asymptote of 0 and a vertical asymptote at x equals 5. Notice how we're getting a lot of depth of learning. I was just going to go say it's this one because I'm telling you why other ones aren't and what is true about them. You see? I think it's a different way of thinking and being taught. But one of them has a horizontal asymptote at y equals 5 and a vertical at x equals 5. Horizontal at y equals 0. Which one is that? Which one has the vertical at x equals 5 and a horizontal at y equals 0? Which one? You guys can talk. I know I'm recording, but it's C. Yeah, thank you. They can't hear through my mic. It's being picked up through here. They won't hear you. So if you're like, oh, I don't want to hear me. Yes, C is definitely not it. And then I might cover the person who's saying, I get why it has a vertical at x equals 5. Why did she say horizontal at y equals 0? Because as x goes to infinity, that denominator's taking over. Or there's a higher power in the denominator, right? Bigger on bottom. Bobo goes to 0. One of them, bless you, sweet pea. One of them has a horizontal asymptote at y equals negative 5. So close. That's D, right? So that's not it. Now, bless you, pumpkin. All right. So between the other 2, you might not know why one of them doesn't work, Jacob, but you should know why the one I'm going to circle does work. Okay? The answer is E. Bless you! Man. If you get to 11, you're going to die. All right, we'll keep track. You're at 3. Jacob, so why is it E?
Because the highest coefficient is the x squared, and 20 over 4 is 5.
Perfect. The answer is E. 4!
He's hot.
Sorry if you're listening to this. Ashley, she's the one who requested. You see, she's gone over there. Somebody's got the sneezes. All right, so this guy right here, you might not know why it's not that one, because this is calculus, not pre-calculus. We're going to talk about limits as we go to infinity. The bottom is heading to infinity, correct? Like to 99999999999, right, Isabel? But the top, you might say, I don't know what sine x is going to as I go to infinity. You don't know exactly, but you know from pre-calc that the most sine can ever be is 1, right? And what's the least sine can ever be? So whatever this is, as you go to infinity, it doesn't really matter. It's between 1 and -1 at all times. So what's this going to go to as a 0? Yeah, that took a lot more thought, right? I didn't even really write anything down, but I'm going, the bottom's going to infinity and the top can't even get past 1. So at most, it's 1 over infinity, which is 0, correct? So it is E, but I didn't want to talk about why it's E. I wanted to talk about why the other ones still work. That one should have made sense to you. You should, that one I call a level 3-4. Like, we should mostly get that one. This, whenever I put 5 plus, it means it's not on my test. Or if it is, it's a bonus. Like, it just adds to your score. It can't hurt it. This is from the 2008. It's the only AP test in history, and they go back to 1962, I think, where a problem got thrown out. Normally there's 45 multiple choice questions. It must have been about 5 years ago when my class, you'll take the 2008 as a practice because it's a public exam. I had my kids go to the scoring thing and somebody said, why is it out of 44? I was like, I don't know, I've never seen that before. So I posted it to my AP reader group because they're kind of in the know, a lot of them, for College Board. And they said that the reason this guy got thrown out wasn't because of the number of people who got it wrong. It's because the majority of people who got it right got a 1 or a 2 on the exam. What does that mean they did?
Yes.
They guessed. The 4s or 5s predominantly chose the same wrong answer. That's why they threw it out. So let me if you don't understand this one, it's okay. But it goes more to the calculus of it than the pre-calculus. You already know that we take limits as we go to the infinities when we're thinking horizontal asymptotes. Are you going to sneeze again? Because you're starting to make me worried. 911! Nope. All right. Okay, Danny, we'd hate to lose you. Especially to something so silly in this crazy world. I just got prophetic. All right, anyway, guys, I'm in a weird mood. You know why? I slept like crazy last night. I fell asleep at 8:30 and didn't wake up till 5:30. That never happens when you're in my age, because you always got to get up and pee, especially if you've had 5 kids. All right, anyway. Oh, God, that's on tape. I'm recording. That's on YouTube. All right, anyway, so, or it will be. Anyway, this guy, let me talk about as we go to infinity. All right. Now you might say, LaRue, you said to look at the powers. Yeah, if it's pre-calc and it's polynomial over polynomial, right? This is not. This is exponential function with 5 added to it, and exponential function being subtracted from 1. It's kind of unique. However, as we go to infinities, the 5 and 1 do nothing, right? So in my head, because it's multiple choice, so I don't have to show a bunch of work, but in my head I'm going, okay, x is getting huge. You guys aren't doing anything. And regardless of what x is, the top and the bottom are opposites. Correct? So -1, actually I think I typed it in wrong. The majority of kids who got a 4 or 5 chose A. The kids who got it right got 1s and 2s. The majority, which means they guessed. The person who circles A for -1 only neglected to go to negative infinity. And or if they did, they didn't know how to do it. So watch as I go to negative infinity. What is 2 to the -5th? 1 over 2 to the 5th, correct? What's 2 to the -99th? 1 over 2 to the 99th. What's 2 to the negative infinity? Basically 1 over 2 to the infinity. Infinity really shouldn't be treated as a number, but I'm doing multiple choice, so I get to be sloppy, right? What does 1 over 2 to the infinity approach as we get bigger and bigger and bigger and bigger and bigger? 2 to the 999999999 power 1 divided by it. What's that going to go to? 0, right? That's going to be gone. Same here. If this was negative infinity, it'd be 1 over 2 to a gigantic power, also going to 0. What should the correct answer be? E. In one direction, we went to -1, and in the other, 5. If you don't get that, nod and smile. It's a 5 plus. But if you do get it, try this guy. I'm just going to give you a minute to try this guy. It's similar.
What was the answer to the first one?
E. So you have to head to infinity and see what happens. Does anything go to 0? Can I wipe anything out? Right now you can't just cross stuff off because right now I don't have like any constants, like just $2 added to my infinite bank account. That doesn't do much. But pretend you're going to positive infinity. Does something disappear? Then go to negative infinity. Does something disappear? Most kids at your level will get one of those, but not both. So remember, horizontal asymptotes in pre-calc are all about those highest powers, but in calculus, sometimes we don't have polynomials, so we have to send ourselves out to the infinities. Maddie, Mandy, what's up with the names going on here? Right, Riley? Just kidding, Tyler. I did it on purpose. Joel, you ready? Joel, if you head to infinity and you're doing multiple choice, which one of these, I gotta check because I'm recording, which one of those just kind of disappears?
Going to infinity. The second one.
The second one, because it's 7 over e to the x, right? So negative exponents go to the basement, and if that's going to infinity, you can try it on your calculator, but 7 divided by e even to the 99th is going to say 0.0000. You get it, right? So you are correct. When I go to infinity, you're out. Joel, what else is out when I go to infinity?
E to the next.
Yeah, 1 over e to the x is going to be 1 over gigantic, right? Those are now tied, technically, so 3. Most kids at your level choose A because they neglect to or don't know how to approach which one? Negative infinity. So watch me approach negative infinity. Now I'm going to use infinity as a number, but I'd have 3e to the negative infinity plus 7e to the negative infinity over e to the negative infinity plus e to the negative infinity. Now what disappears? This. It's 3 over e to an infinite power. That's got to go to, you can try it on your calculator. But like I said, even 3 over e to the 99th, that's going to 0. This is also going to go. Now they would be tied. So what's your other answer? 7. Did any of you see that? If so, that's a 5+ level. If not, just go, I did. You'll never know. If you're watching the video, I'm nodding and smiling. We are not doing slant asymptotes. Take out your worksheet 1.15 and cross them off. They're the last 2. Somebody tell me what numbers they are. We'll write skip 27 and 28. There are no slant asymptotes on the AP exam. I don't even know if you learned about them in pre-calculus, but we're predominantly concerned with vertical and horizontal for a reason. Okay, that you don't know yet. We haven't really applied anything. The calculus is an applicable math, so we're going to be doing some really cool stuff. None of it will involve slant asymptotes. So now we're going to move on to our next section. Understanding this theorem is a piece of cake. Being able to write it out is extremely difficult, okay? Because writing math is hard. We're going to work with something called the intermediate value theorem. You're allowed to abbreviate it IVT. And that's universal. Anyone in calculus knows what the IVT stands for. It's called an existence theorem. You're going to learn 3 of them this year, one of which isn't very important. So technically, you need to be masters at 2 of them by May. This is the first one. Okay. The other one's going to be called the MVT, and I believe it's in our chapter 3 or end of 2. I can't remember. It guarantees the existence of a number. Because historically, this kids tend to get, but they don't get it if I did this. Hey, guess what, Mandy? Say what? I'm going to teach you the IVT today, okay? Say yes, please.
Yes.
The IVT states that if f is continuous on the closed interval from a to b and k is any number between f of a and f of b, then there's at least one number c in a b such that f of c equals k. All right, go to work. Do you get it? No. This is a lot of math jargon, so we're going to put it into a real-life situation. Bethany, we're going to take x out and call it t for time. By the way, once we get out of chapter 1, almost all our problems have a t-axis, because calculus is about change and rates of change and accumulations of change over time. So we almost always will be having t's. Not this chapter, because this chapter is just kind of getting us going. And I'm going to tell you about when I got in my car this morning. And I got in it, let's say, 1 hour after I woke up. So I'm just going to call this hour 1. And when I got up, And so my x-axis is now considered hours. My t-axis is degrees Fahrenheit. My temperature gauge, I'm just gonna go like this to show that I'm squishing this down, said it was 48 degrees. So I have this point technically that represents time, temperature at that time, and it's the point 1 hour in 48 degrees. And then when I get home, let's pretend, okay, and that's 7 hours after I got up. I think the high today is supposed to be 64. So I'm going to go up to 64 and say I also have this closed dot at 7,64. Are we good with that? That in this scenario is my interval from 1 to 7. Go ahead and write that on. That's what that's talking about. There's some interval on the x-axis that we're working with. In this case, 1 to 7. It says k is any number between these two. Those are y values, right? F of a would be f of 1, which is 48. These are y-axis values. In my scenario, it's the beginning and ending temperature. When you do it generically, it's the beginning and ending of anything on the interval. Where does it start? Where did it end? Continuous, we know what that means. I will never lift my pencil as I travel from one to the next. All right, so suppose the temperature went up, and then maybe at noon it dipped a little bit, and it was like, oh, it got a little cloudy, and then maybe flattened, and then went up. Let's suppose that is my temperature graph for the day. It's continuous, right? You can't jump from 60 to 70 without passing through, right? Here's what this says. That as long as k is between these two, so I'm going to go put this, I'm going to call it the k that they're talking about. Let's suppose that that represents 52 degrees. Wouldn't you agree that if the temperature rose from 48 to 64 over that time interval, then at some time it had to be 52 degrees? Yes, at least once. It could have been more. It could have kind of dinged around or oscillated, like might have gone like 53, 51, 53, 51. You know what I mean? And then shot up. But at least once you have to hit it. Go ahead and do that. Drop it down. It guarantees at least one C. That's an X value. In my case, at least one time. So go put a little C right there so you know that the C is on the X-axis. Such that I reach that temperature. So loosely it says that for a continuous function, every Y value has to get hit at least once between the X values. Has to. Does that make sense? But now, watch. There's some things you have to be careful of. First of all, continuity. You can see this Y value, maybe if it was 5, it never got hit because the function jumped. So you have to verify that the function is continuous. When you're doing delta math, if it doesn't say the function is continuous, you're going to say the function may or may not be continuous, so I either may or may, you might hit it, but maybe you hit it over here, but it's not guaranteed. Okay, so we need continuity. All right, so we'll give you the example 1. There's only 3 of them. So example 1 says that my time, or t, or x, is from -3 to 9. 3 hours ago, 9 hours from now. Think temperature. 3 hours ago, it was 0 degrees. 9 hours from now, it's down to 12. So basically, it started at 0, it ended at -12. Does that make sense? This theorem guarantees that there has to be at least one x value between which two numbers? Be careful. One x value between which two numbers up here? -3 and 9. Yep. This is that C that they're talking about. There has to be at least one number in there such that f of C has to hit every number along the way. There's only one of these that meet that criteria. See if you can find it. There's only one of those that could possibly be made using the intermediate value theorem. Continuity was stated, so that's good. We always look for that. But there's only one of them where the x is where it should be, and the output is where it should be. You're nodding back there, right? What does A violate? What's out of the interval? The X. This might happen, but I'm not guaranteed it. It may or may not. Would this be an okay statement? What's it violating? Both. Well, actually, -1 is in there. So it's violating the output, -13. It might drop to -13. I don't know. Right? How about this one? Is -2 where it should be? Yes. Is the output somewhere where it should be? Yes. Okay? So, now, if you were taking this class in college, they're primarily algebraic like this one. I'm going to tell you, College Board is not a fan of that. They like you to understand what it means in context. So I'm going to show you, if you were taking it at like UMD, it'd be a question like this. If you're taking it, I like to hit both. It would give you some generic function. Okay? And it says use the IVT, so I don't even have to know what I'm using. That has a 0. What does it mean for a function to have a 0? It means it hits the x-axis or that its y value is 0. So really what you're being asked is to prove that this function has to sail through 0. So you're going to do what I talked about with the temperature. Here's your time interval. Really, it's X interval for college. They don't normally do the application as much, but you still need to know what you're doing. You're going to have to say, well, where is the function at the start of the interval? You plug it in. It's not hard. 0 cubed plus 0 minus 1, boom. This function at the start of the interval, regardless of what it looks like, at the start of my interval, it is right there. Then I'm going to see what happens at the end of the interval in question. Not the end of the function, the end of the domain that I'm analyzing. And I go 1 cubed plus 2 times 1 minus 1, which is 2. So you might say, I'm just going to go look on my calculator. You wouldn't have one. So your function, is it continuous? Doesn't say it, but are polynomials continuous? Yeah, x squared, x cubed. They're all, every degree on a polynomial adds another row in the graph. Did you know that? The cubes are 1, 2, cortex look like m's or w's, right? So, now how do I write this? You just can't move on. You have to state why I'm guaranteed that if I go from -1 to 2, regardless of how I do it, don't I have to hit the x-axis? I can't not hit the x-axis. Wouldn't you agree? There has to be a 0, but this is where the other class was struggling a little bit. How do I write that? First of all, if I said this, if you're wearing blue, you get an A on Friday's test. What do we all do? I'm wearing blue, right? If not, you're like crap. So the hypothesis has to be met. So you have to say since, and it's not me forcing this is College Board. Since F is continuous. You might say, how would I know that? You really wanted to continuous. Sound smart. You could say all polynomials are. You can't make a polynomial that jumps. Like they're roly-poly. There's a 5th degree for it. All right. Since F is continuous, now you have to do what we did. What did we check first? Because we have to write out our math. We did. We said with my starting point being at -1, thank you, my dear, and my ending point on the interval being at 2. What about those two numbers made us go, yep, has to hit 0? Because you have to state that. What is it about the -1 and the 2 where you're going, yep, has to be? 0's between them, right? So you're going to say, and I'm noticing that 0 is between those two. This is the hard part, knowing how to explain yourself. So, for the IVT, the function must be continuous. You need to figure out what happens at each end. If the number, like when you're doing delta math, if this had said, prove that f of c equals 4, you would say it may or may not. I don't know, it might hit 4, but I'm not guaranteed it. Does that make sense? Like it might swing up and hit 4, but the IVT doesn't guarantee that. All right, the IVT, you should always state, you're only going to have 2 of them. There's another one called the MBT. But what does the IBT do? Guarantees exactly what we said. Guarantees at least one. In this problem, it said a 0. So you can call it an X or a C or whatever. But where does that, you could say at least one X value or at least one C. Where does it, I can't go away from my board, sorry, because I'm recording. Where does that number have to lie? Between 0 and 1. So you can say like this in the interval, like this. But if you would rather use this symbol, that means an element of. It means there has to be at least one C in there. Such that what happens? My Y value is 0. That is hard. The concept isn't hard. Here it is. If you go from -1 to 2, Bella, if you go to -1 to 2 on a number line and don't lift your pencil, guess what? You have to hit 0. She's going, that's a 3rd grade concept, right? And guess what? If you go from 4 to 9 without lifting your pencil, you have to pass through 8. You're like, no shit, right? But look at what you have to write. You know what I mean? It gets tricky. So let's go over here and wrap it up with our last one. This is how College Board tests it. So some people say, I heard AP Calculus is easy. Oh, no. No. But once you get the language down and we can teach you how to pick all this apart, it's actually easier than pre-calculus. It really is. This question is not hard. But look, right? Holy crap. First of all, this was in 2007, and it was just part of a question. It was just part A. These 2 columns were used for B and C. You don't know what that little prime symbol means yet. You will in about a month. So for our question, we just need that part of the table. We also, for our part of the question, so I told you these are always scored out of 9. There was a part B and a part C, but you won't. It'll be months before you can do a whole FRQ. Does that make sense? But I don't want to wait that long to get you used to the language. So we've got F and G, and they're continuous, right? Here's the function H. That's pre-calculus. That's function composition. You put G into F and then subtract 6. This is not calculus right here, right? So you should know how to find like H of 2, F of G of 2 minus 6, right? Now what does it say? Explain why there must be some value. Oh, what's this R? Well, it's an X value, because I can see it's being put in between 1 and 3, such that the Y value is -5. Guess what I do first to verify that I have to hit -5? Think about it. This is saying that I need to explain why I have to hit -5 on that interval. Think ahead. What do you think I'm going to do first? What'd you say, hon?
You put 1 in front.
Yeah, we do. We have to say, well, where on H am I at the beginning? That's kind of like, what temperature was it at 1 hour after I got up? You might say, this isn't temperature. No, but it's all output inputs. You're excellent, you two. I think you two said it. I need to figure those out. How do I do that? That's pre-calculus. Because H is F of G of 1. This is not a hard question. But picking it apart is really hard. All right. So how do I do F of G of 1? Well, I go to the table and I look. What does it say the G value is at 1? I don't know. I can't see it. It's 2, right? So I need to do F of 2. What does it say F of 2 is? What did you say, 9? Or can someone agree? Because my table's chopped. Okay, you're nodding. So it's 9 minus 6, it's 3. What that's saying is I can't see H. I have no clue what it looks like, but the point 1 comma 3 is on it. You guys go find H of 3. And if you're wondering why I chose these numbers, they're the ends of my interval in question. I'm figuring out, does this make sense, Joel? It's hard, but it's so easy. Go figure out H of 3, same way. Pre-calculus, put 3 into G, see what it poops out. Put it into F, see what it poops out. Subtract 6. And I have no idea what it is. So I'm going to wait for blurters. -9? -6? 7? Which one is it? -7. There you should be going, oh, I like that. Are you convinced that if you don't lift your pencil on your way, you must pass through -5? But if you just write yes and move on your way, this student would get 1 of 3 points. Okay? Because you did not explain anything. You gave me 2 numbers. Does that make sense? So, as an AP reader, I know how these are graded. The very first thing it's going to say is student verifies hypothesis is met. What do you think they mean by that? Since what? H is what? Continuous. If it wasn't, you can't apply this theorem. If you are wearing red, you get an F. Right? You look for the F part. That would give you 1 point. Then these numbers would give you 1 point. Okay? Now, since you already wrote the work out there, but I'm going to do this. You don't actually need this arithmetic, but you do need to, like suppose Tristan did that in his head. He's like, that's not calculus. There's going to be no point for the arithmetic and the pre-calc here, but you do need to state what you, does that make sense? The points are only for calculus. And he's going to say maybe he did it in his head, but he got h of 3 equals -7. There's your other point. 1 for continuity and 1 for getting these values. And your last will be the concluding statement. What do you think I have to verify? -5 is between the two. So and you can just write it like that, but I like when kids kind of link it like with a with or and or something. Now you can make the conclusion. What theorem are we using? The IVT. Sometimes that's a point, usually not, because you usually can't read the kids' abbreviations, so they usually don't care. But you can say, I can conclude, but. The IVT guarantees. Look at and go read. What am I supposed to guarantee exists? It says.
H of R equals.
Yes, there's at least 1 R. Guarantees. And R, at least 1. I better put lowercase because that's what they used, right? And R, where does that R have to fall?
-5.
No, the R value. Between 1 and 3. I told you can write it like this if you want, or you can use the interval notation, and then such that I have to pass through -5. But you should say what Bella said, h of R equals -5. That will get you 3 for 3, no matter who your reader is. Most of the time, you don't have to specify the theorem, and you don't have to show the arithmetic, but everything else you need. Are we good? We're done. So, you're going to go to Delta Math. There's an IVT with 3 problems. Be very careful. Number 1, make sure they say the function is what? Continuous, because last hour they just read over it quickly. And if it's not continuous, you may or may not be. You don't know. Oh, I just blocked this out. All right. When those 3 are done, I'm just going to repeat this for people at home. This is your order of operations today. Delta Math, get 3 right. Most of you will do that before you leave. All right. So Delta Math. Then 1.15 worksheet. If you already did it, is anyone pretty much almost done with that? If so, yeah. Then move on. Make sure you look at the key maybe, but then move on to 1.16. It's not a long one. I'll pass it out. If that's done, chill when it is. But tomorrow you'll start the chapter review. But this is what's due tomorrow. The 1.15. I thought I had my highlighter activated. Apparently not. And I want you to get the Delta Math, just so you kind of know what this theorem states. I'm going to grab my 1.16 for you and stop the recording. 1.16 due Thursday. When? But some people are done with 1.15. So I like to kind of keep things fluid in here because maybe you work tonight until midnight. Right? And you should have done 1.15 last night. You had some time management skills. Maybe you have a tennis match.
I do.
What the heck? Good. Then hopefully you did 1.15 last night. You can save this one. This one's due Thursday. When's it due, Riley? All right, so right, due Thursday on the top of 1.16. Delta right now, you're probably going to get a red X at first. That's why I give Delta. It's going to force you to go read how you should write it. I give you an extra. And then fix. What's that?
That's homework.
Hi, absent people. Oh,